All right, people. I believe everybody is doing great, nice, and absolutely fine. So, welcome to this beautiful session. Welcome to this beautiful session. Let me know in the chats if I'm perfectly audible and visible to each and every single student. And my dear friends, we have the next session today. That is what we call the Newton's laws of motion part 2. And we have to finish this particular chapter by today only. Okay, so that's for sure, we will be completing it, okay, for today only. And I would want you guys to hit the like button if you have not liked this session yet. Hit the like button as soon as possible, because liking this session is extremely mandatory. Okay, so everyone means everyone, guys, and call up your friends, everybody, so that we can start this particular session and we can complete this particular session today only. Okay, great. And let the people join once everybody comes, and then only we can start this particular session over here. So today is the second part 2 of this particular laws of motion. Okay, so there will be only two parts. We'll have to complete this chapter by today only, that's for sure. Okay, so we'll have to be very aggressive today, then only we would be able to solve this particular chapter. So tell me in the chats, how is everything going? Tell me in the chats, how is everything going, guys? Is everybody doing great? And make sure you hit the like button. Liking the session is extremely mandatory. Liking the session is extremely mandatory. All the people out there, hit the like button as soon as possible. So I believe that in the last session we had completed the second law of motion, okay, that we completed in the last session. So from today onwards, we'll have to solve some of the questions in the second law, and then we will move on to the rest of the topics that we have to cover in the today's portion. Okay, now my dear friends, without wasting the further time, I guess we should start this particular session. And marking the attendance as mandatory, hit the like button, everybody out there. Guys, the very first topic that we need to start today is, we say, rocket propulsion, is what we call the rocket propulsion. Sir, what is this rocket propulsion all about? Understand whatever I'm going to say. Okay, guys, we have got a rocket over here. Okay, since you guys know that, we said this rocket goes up. When we basically launch the rocket, we say it goes up. So at that point of time, you can clearly see over here, what is this? This is fuel burning over here. Okay, so when fuel is burned, so when this rocket burns the fuel, we say those exhaust gases come out of this rocket, and that pushes the rocket in the upward direction, due to which we say rocket goes up. So I hope you got it what I'm trying to say. So we say if you have got a rocket over here, like, guys, if we say what is rocket propulsion, let's suppose I have got a rocket over here. Okay, we said this rocket basically burns the fuel. Okay, but fuel has got the mass, it has got a large fuel in it. Okay, and once it burns the fuel, so because of that, it sends out those exhaust gases. Because of that, it is being pushed in the upward direction, and that pushes what we call the thrust. Okay, so because of that, we say, sir, it gets this thrust. Okay, it gets pushed in the upward direction. So, and after that resulting, we say, sir, as the rocket keeps on burning the fuel, okay, we say it keeps on going up. If we use the Newton's second law on the rocket, guys, understand very carefully. Let's suppose I say acceleration of the rocket is A. Okay, could you please tell me in this particular case, guys, we say what is the force which is acting in the downward direction on this rocket? Sir, there is only one force which is acting in the downward direction. We say, sir, that is m into g. Okay, if I say I have got an object over here, what is the force which acts on this particular object in the downward direction. We say, sir, that is mg. Mg is the force which acts in the downward direction. Just a second, guys. We say mg is the force which acts in the downward direction over here. Now, guys, you tell me one thing. All the people out there, you guys tell me one thing in this particular case. This is the mg force. We say the force in the upward direction is F thrust. Force in the downward direction is, we say, sir, mg. And if I ask you to use Newton's second law over here, we say use Newton's, we say second law here. Guys, could you please tell me, in this particular case, is the mass of this rocket constant over here? We say mass of the rocket is not constant. Why? Because as it keeps on burning the fuel, we say the mass of the rocket keeps on decreasing. Mass of the rocket means the mass of rocket plus the mass of fuel. So as the fuel keeps on burning, we say mass of the rocket is decreasing. My dear friends, can I say in this particular case, listen to me very carefully. What is the force when mass is variable? If you remember in the last class, I told you force is equal to dp divided by dt. Force is equal to change in momentum upon change in time. And then I asked you, sir, F is equal to, we say this is a d by dt of, instead of this momentum, it is m into v. If mass is constant, we say m comes out. In that particular case, you write m, then dv divided by dt. Okay. And if mass is variable, in that case, I told you this formula, F is equal to, take velocity out, we say this is a dm divided by dt. Because here, mass is variable, mass is changing, dm by dt is change in mass. So this is the value of force when mass of the body is variable. Now, in the same case, can I use, we say here, I can clearly say over here, this F thrust will be simply, that is, I say V, that is a dm divided by dt, V dm by dt. Okay, this is basically the F thrust. And what is this dm by dt in this particular case? This is, we say rate of change of mass, okay, or you can say rate of combustion of fuel. Okay, how fast mass is decreasing, how fast fuel is decreasing. So that is what we call the rate of combustion of fuel, in this particular case dm by dt. So when fuel burns, when this mass decreases, we say it gets the F thrust. Because of that, it gets this thrust force in the upward direction. And what is the force acting in the downward direction? That is mg. Okay, what is this m? M is the mass of the entire rocket over here. Now we say, as we say Newton's second law says net force is equal to mass into acceleration. Now guys, what is the net force? In the upward direction, you have got F thrust. In the downward direction, you have got mg. So can I write, sir, upward minus downward? That will be the net force. Upward minus downward. So upward is V dm divided by dt minus, we say, mg. Okay. So this is the force which gets up when it burns the fuel. dm by dt is with what rate it is burning the fuel. What is the rate of combustion? What is the rate of combustion of fuel? Okay. And then is equal to, we say over here, mass into acceleration in this particular case. Okay. Okay. So this will be the formula which we need to use in case of rocket propulsion. I hope this is clear. Guys, what I'm trying to say, if this rocket burns the fuel, so how much fuel it is burning? That is dm by dt. Every second it is burning the fuel. Okay. And v is the velocity of the exhausted gases over here. And because of that, it is getting this F thrust. Because of that, it is getting F thrust. And in the downward direction, there is force mg. Now, how much is the net force over here? Net force in this particular case is simply, that is, up this F thrust minus, we can say in this particular case, mg. That's why net force is equal to mass times of acceleration. Guys, is this clear? Please let me know in the chats. I would want all of you to tell me in the chats. Is this clear? Is this clear? Everyone guys. And if you have not liked the session, I would want you guys to hit the like button as soon as possible. Great, great. Now, this is the formula that we will be using over here right now. Now, let's have a look at the question. Let's have a look at the question. For a rocket propulsion, with the help of this question, you would be able to understand what I was explaining. For a rocket propulsion, velocity of the exhausted gases relative to the rocket is 2 kilometer per second. 2 kilometer per second. Guys. I say I have got a rocket over here. I have got a rocket over here. Okay. These are the exhaust gases. These gases are burning over here. These are the exhaust gases. It says that velocity of the exhaust gases, how much is that? That is given as, we can say, sir, 2 kilometer per hour. 1 kilometer is 1000 meters. So 2 into 1000 becomes 2000 in kilometer per second. So it becomes, that is 2000 meter per second. Velocity of exhaust gases. If the mass of the rocket is 1000 kg, it says that mass of the rocket is given as 1000 kg over here. Understand very carefully. Then the rate of fuel combustion for a rocket to rise up with an acceleration of 4.9 meter per second square will be. Guys, it says that we have got a rocket. Velocity of exhaust gases is given as 2000 meter per second. And mass of the rocket is given as this much. And it says that acceleration of the rocket is also how much? 4.9 meter per second square. We can consider it 5 also. Now, my dear friends, in this particular case, it says, what is the value of dm divided by dt? Means with what rate fuel is burning over here? With what rate fuel, what is the rate of combustion? How fast the fuel is decreasing in this particular case, dm by dt. This is what we are supposed to calculate. Guys, I have told you one formula that you guys need to use over here. V dm by dt minus mg is equal to m into a. I'll use the same formula. I have to find the value of dm by dt. Then the rate of fuel combustion for a rocket to rise up. How much is the rate of fuel combustion? So that the rocket should rise up with an acceleration of 4.9 meter per second square. So I'll use the same formula. As we know, we say V dm divided by dt, then we say minus, that is m into g. We say m into g is equal mass into acceleration. This is the mass of the rocket. Keep that thing in your mind. And this dm by dt is how fast fuel is decreasing. So I can say, what is the velocity given over here? That is given as 2000. And then I'll write as dm divided by dt. Then I say minus. What is the mass of the rocket? That is given as 1000 kg. And this is 1000 over here. What is this g? G is what we call the acceleration due to gravity. And always remember, we take acceleration due to gravity as 9.8 meter per second square, or approximately we take it 10 meter per second square. Okay. So we can write over here multiplied by 10 is equal to mass into acceleration. Mass is how much? 1000, and acceleration is given as 4.9. Consider it 5. So consider it 5 over here. Okay. Now, my dear friends, I can say in this particular case, so this will be over here, that is 2000, and this is dm divided by dt. Then I'll write minus over here. This is 1000 into 10. That will be how much? 10,000. 1000 into 5 is 5,000. If I take it over there, it will become 5,000 plus 10,000 is equal to 15,000. So I'll write over here, this will become 15,000. Okay. Now divide this 2,000 with the 15,000 over here. So can I write in this particular case, dm divided by dt will come out to be, that is, I'll write simply 15,000 divided by, I'll write 2,000 over here. This will cancel. So 7.5 kg per second. 7.5 kg per second means every single second it is burning the fuel of how much? 7.5 kg per second. Okay, so here the answer is 7.35 because we have taken the approximately over here 5, and here also we took approximately, we say 10. That's why we got 7.5. The actual answer has to be 7.35 kg per second. Guys, is this clear? Is this clear? Please let me know in the chats. And if you have not liked this session yet, I would want you guys to hit the like button. Everybody. Everyone means everyone. Everyone means everyone. Hit the like button, all the people out there. Okay, great. Now let's take a look at the next question on the similar topic. If the force on a rocket moving in force-free space, free space means where there is no gravity. It's a gravity-free space. So there is no mg acting on the body in the free space. Okay. With an exhaust velocity of the gas as 300 meter per second. It says that we have got a rocket over here. Okay. We have got a rocket over here. And exhaust velocity of the gas is given as V is equal to, that is 300 meter per second. Okay. If the force on, and it says that if the force on a rocket moving in a force-free space with an exhaust velocity of the gas is 210 Newton and force F thrust in this particular case is acting as 210 Newton, then the rate of combustion of fuel is, here force is given as, we say 210 Newton means because of this exhaust gas, 210 Newton force is acting on this rocket, and we say velocity is given as 300 meter per second, and it is saying that gravity free space means there is no gravity. You can directly see over here, guys, you can directly see over here, as we know this force is equal to, that is V dm by dt, okay, V dm by dt. Simply you can use this particular formula. Now force is given in this particular case as 210 Newton. Okay. Force in this case is given as 210 Newton is equal to, velocity is given in this particular case as 300, and then we can say dm divided by dt. And further you can write over here, this dm divided by dt will come out to be, that is 210 divided by 300 Newton over here. Guys, is this clear? Is this clear? It is given as the gravity free space. That's why I didn't take over here gravity. I say gravity in this particular case is 0. Okay. Gravity in this particular case is 0. Okay. So I can say this will come out to be 0.7. We say kg per second. So this will be the rate of combustion of fuel in this particular case. Yes, a lot of people are mentioning over here over there in the comments. So 0.7 is absolutely the correct answer. 100%. Okay. Now guys, let's move on to the very important topic. That is what we call the forces in mechanics. So I have told you, till now I have explained how we are supposed to apply the Newton's second law in different cases, be it the rocket propulsion, be it the normal cases, and there are many more cases, there are many more things that are about to come that we have to study today. Now guys, see, forces in mechanics. What are the different types of forces that we have to understand over here? Guys, see, The first one is that is what we call the weight. The first one is that is what we call weight. Sir, what is this weight? I'll make you understand, guys. Let's suppose I have got a table over here. I have got a table over here. Okay, okay. We say, my dear friends, in this particular case, I have an object placed on the table. I have an object placed on the table. Everybody of you know that, sir, there is a force acting on this table in the downward direction. Means, Earth is, if I say I have got a pen over here, we know that Earth is attracting this pen towards itself with a gravitational force. Same will be case over here if its mass is m. We say force on it will be towards the Earth. That is what we call the gravitational force. And what is the value of that? That is m into g. Mass of this multiplied by acceleration due to gravity. Mass of this multiplied by acceleration due to gravity. And this is what we call the weight. You can see clearly the definition over here. It is a gravitational force or gravitational pull by Earth. How much force Earth is applying on any object, that is what we call the weight. Okay, weight is a force. Weight is a force. Keep that thing in your mind. Like if I say I have got over here this object, its mass is 1 kg. Sir, how much is the weight on this one? Sir, we say 1 m, mass is 1. G is 10, acceleration due to gravity. 1 into 10 is 10. That is 10 Newton forces acting on this one in the downward direction. Okay. It is always vertically downwards. On any object, we say it is always vertically downwards. Mg is always vertically downwards. Okay. And its magnitude is, we say mass into, I'll write over here, mass into acceleration due to gravity. Mass into, we say, acceleration due to gravity. Mass into acceleration due to gravity will be the value of force. So W is equal to, you can write over here, M into G. W is equal to mg. Is this red color visible? Please tell me in the chats. Is this red color properly visible? I am writing with the red color over here. Is this visible? Is this visible? Is the red color visible to each and every single student? Okay. Now guys, see, now, just a second. So basically this is what we call the weight. This is what we call the weight. Let me give you some of the examples over here which will make you understand about this weight. Okay, now guys, understand very carefully. Let's suppose I say I have got over here a block. And this angle in this particular case is theta. Always remember that. Force acting on any object, weight. This gravity is always in the downward direction. Okay, this is mg. Now here, you can resolve this mg in two components because we always resolve the vectors in two components. So this vector can be resolved in two components. First will be this and second will be this. If this is theta, we say this is also theta. So this component will be mg, we say cos of theta, and this component will be mg, I can say sine of theta over here. But the actual weight, the actual mg will be in the downward direction. Keep that thing in your mind. Okay. Let's suppose I have got a rope over here. Okay, this is a string, this is a rope attached to, we say, the ceiling over here, and then we have got a mass over here. We say on this mass in the downward direction there is a force which is acting, that is m into g. M is the mass of this object. We say g is the acceleration due to gravity. Keep that thing in your mind. Okay. Next we will move on to the next force. That is what we call the normal force, or we call it the normal reaction also. We say it is normal force, or we say it is the normal reaction also. Now guys, in this particular case, We say, what is the normal force? Guys, see. It acts whenever the two surfaces are in contact with each other. We say whenever the two surfaces come in contact with each other, they apply a force on each other called the normal force. Like. I say, let's suppose I have got a table over here. This is the table that I have got. And on this table, I am placing a block. On this table, I am placing a block. So we say here, the two bodies are in contact with each other. So this table and this block, they are in contact with each other. So I can say this table is applying the force on this in the upward direction, that is normal. And this block is also applying the force on the table, that is, we say n dash. We say this and this will be equal. If this is, let's suppose this is one surface, this is one object. If this is applying 10 Newton force on this object, this will also apply the same 10 Newton on this object. So we say this is normal force on the upper block, this is normal force on the lower block, I can say over here. Let's suppose I say I have got the two blocks over here. I say I have got the two blocks over here. Okay, I have got the two blocks over here. And this is the second block. This is the second block. They are in contact with each other. Now, sure, you can say the normal forces will be something like this. This block is applying the normal force on this one. Let's suppose that is N. This is also applying the normal force on the another block, that will be N dash. But these two normal forces are acting on two different bodies, This N dash is acting on bigger body, this N is acting on this smaller body. And from this side also, this surface is applying the force on this one. Let's suppose this is also N double dash. This is also applying force on this one, that is N triple dash. So here also there will be normal reaction. So whenever the two bodies come in contact with each other, they apply the force, that is what we call the normal force. Okay, it is always perpendicular to the surface in contact. See guys, I made it perpendicular to the surface in contact. It is always perpendicular. It makes 90 degrees with the surface. It is always a pushing, it is always of pushing nature. It's a push based force. This body and this body, it is pushing it with the normal force. It's a push based force. Okay, then we have got the tension force over here. Sir, what is this tension force? We say it is the force which is generated in the string. It is the force which is generated in the string. Guys, see, let me give you the example over here. Let's suppose, my dear friends, I say I have got an object over here. Its mass is m. Is there any it is connected with a rope, it is connected with a thread which is connected to the ceiling. I am asking you one single thing in this particular case. Is there any force which is acting on this object? Yes, sir, that is in the downward direction, that is m into g. mg is the force which is acting on this block in the downward direction. Now, tell me one thing. Is the block going down? We say, sir, no. The block is still over here at rest. Why? If the force is acting on this block, still it is not going down. Why, sir? We say here, one more force will be acting on this block, that is tension, that is in this string. Whenever you have string, means there is a tension in the string, there is a tension force in the string. So we say this upward force is balancing this downward force. So we say here T is equal to mg. That is the reason the block is not going down. That is the reason the block is not going down. That is the reason the block is not going down. T, because T is equal to mg. Okay. So tension is the force which always exists, we say, in the string, okay. Let's take a look at few more points over here, and I hope all of you are making the notes over here. Okay, it acts in a stretched string or rope. Guys, when you have a rope that is stretched, okay, if the rope is loose, we say in that case there is no tension. It has to be stretched, okay, we say then tension will act. Okay, next, it is always of pulling nature. We say, my dear friends, you check over here. We say tension forces, it is pulling the block, it is pulling the block. It is not pushing the block, so it is of pulling nature. We say here it is something like this, and here tension will be something like this. It is always away from the block. It is always away from the block. You can see over here, away from the object. Here also it will be away from the object. But it's of pulling nature. Next we say over here, it is same for an ideal string on every point. Guys, if I say I have got a string over here, whatever is the value of tension at this point, same will be at this point, same at this point, same at this point. If the string is same, we say tension will be same. Like I say I have got the string something like this. I have got the string something like this. I'll make a block over here, and then I'll make one more block over here. Guys, see, you have got the two different strings. If the string changes, always remember tension changes. We say for two different strings, we say tension is different. Tension is different. For two different strings, we say tension is different. Okay. Now guys, we have got this block, we have got this block. We say in this particular case, tension in this string will be, let's suppose, T1. Here it is away from the block. Here also it is away from the block. Here it will be T1. But the rope is different. Here tension will be T2, and here also tension will be T2. If the rope is same, in this case, tension at every point is same. In this case also tension at every point is same, but value will be different. Okay, here also it will be same, here also it will be same, but together it is different. Okay. Okay. It is same for an ideal string on every point. Okay. And let me basically give you some of the examples out there in which you will have to basically draw the tension over here, Let's suppose I'll give you the example something like this. Guys, I have got, this is what we call the pulley. I will teach you this also. This is what we call the pulley. And you have got a mass over here, that is M1. And you have got another mass over here, that is M2. This is M1 and this is M2. Now guys, in this particular case, you see, if this is a rope over here, in this rope you have got tension, let's suppose T. Now here also it is the same rope, so it will be having the same tension T. Now the rope is once again same. Guys, it's a pulley, so the rope is same from here to here. So we say here also tension will be T, here also tension will be T. In this case, this is not a different rope, but in this case, there will be the same tension in this particular case. If the rope changes, we say tension will be in that case different. Okay. Now guys, let's move on to, I'll show you the questions on every single topic. Don't worry about it at all. Now guys, let's talk about the free body diagram. What is free body diagram all about? See. This is also called the FBD. This is very important when it comes to the Newton's laws of motion. This helps us to solve the bigger problems. Okay. I would want you guys to listen to me very carefully. How to make a free body diagram of an object. Guys, see, we said to make the FBD, free body diagram of an object, draw all the forces acting on it. The very first step is you have to draw all the forces acting on the body. Let's suppose, is there any example that I have put up over here? Okay. Let's suppose I say I have got, this is a table over here, and on this table I am taking this particular block over here. Okay. What is the first thing in order to make the free body diagram? We say the first thing is draw all the forces. What is the force? Sir, on this block in the downward direction, we say mg is acting. Okay. On the downward direction, mg is acting. What is the force acting on the block in the upward direction? We say, sir, that is normal force. because this table would be applying the normal force on this block. Okay, once you are done with the forces, once you are done with drawing the forces on the block, now make it something like this over here. In the downward direction, we say it is mg. In the upward direction, we say sir, n. Now make the equation. Can I say in this particular case, we say n will be equal to m into g? Yes, I can make this equation and write this, n is equal to mg. What is the first thing to do? Sir, draw all the forces acting on the body and then balance those equations and you will get the free body diagram. Okay, now let's make make FBD for the given mass. Guys, what is the first thing we are supposed to do? The very first thing we are supposed to do is draw the forces acting on the body. What is the force over here? Guys, if this is mass, we say in the downward direction, it will be obviously mg. It will be obviously mg. Now, tell me one thing. Is there any other force? Sir, this surface and block are in contact with each other. Okay. So they apply the normal force on each other. Can I say on this mass, in the upward direction, normal force will be n. In the upward direction, normal force will be n. I know on this surface also normal force will be there. But since we are talking about this mass, so we'll have to make sure that we draw the forces on the mass only, not on this block also, on this surface. This is one force, this is another force. And here you have got a rope. So in the rope, we know that there will be tension. If there is a rope, we say there is tension. Now tell me one thing in this particular case. Tell me one thing. Guys, if this is mg, I need to change this because a lot of students are saying. Okay. Now guys, if this is mg, I told you that this angle would be also theta. If this is theta, so this angle would be theta. So this component will be simply that is mg, we say cos of theta. And this component here will be simply that is mg, I say sine of theta. Now guys, see. Remember this, I have told you many times, if we have got this vector a, and if it is making angle over here theta. So if theta is from this side, then you have to take this as cos component. So it will be cos of theta. And other one will be a sine of theta. It depends upon theta, from which side theta is. If theta is from this side, this will be cos theta, this will be sine component. Same is the case over here. If this is theta, this will be cos component and this will be sine component. Now make a body over here. Sir, I'll make the same body over here. What is the force acting in the downward direction? This mg we have resolved now. Forget about this mg. So in the downward direction, you have got the force as we say, sir, mg cos of theta. What is the force acting opposite to this in the upward direction? Sir, that is normal force. What is the force from the left side? Sir, that is, I can say mg, then it is sine of theta. What is the force from right side? That is, we say, sir, tension. Now balance all the forces over here. So I can say here, since the body is in the equilibrium, means net force on the body is 0. It is not moving. Upward force is equal to downward force. Left side force is equal to right side force. So I can say N is equal to, that is mg cos of theta. And we can say this tension is equal to mg sine of theta. That is mg, I can say sine of theta. This you can write over here, making the equations afterwards. Is this clear, guys? Is this clear? I would want you guys to tell me in the chats if everything is crystal clear and sorted. Okay. Now we say draw the FBD of the given mass, You have to draw the free body diagram of this given mass over here. Guys, understand very carefully. If this is a mass, we say in the downward direction, one force will act, that is mg. And here you have got string. So obviously here tension, it will be T1. It will be T1. Now guys, if this is theta, this angle is theta, we can say this angle would be also theta. This angle would be also theta. You might have studied this in the 8th class. If this is theta, this is also theta. Okay, yes. Now guys, understand one thing very carefully. What is that? If you have got another rope, this is one rope, you have got another rope. Don't you think that in this rope tension will be different? That is T2. If the rope is different, tension is different, so that is T2. Now, if this is T2 and this is theta, don't you think that this component will be simply that is T2, we say cos of theta. If we resolve this in two components, T2 cos of theta. And here in the upward direction, this is T2, we say sine of theta, T2 sine of theta. Now we are done with drawing all the forces acting on the body. Now make this body over here. Guys, let's make this body over here. This is M. Guys, this was at theta. That's why I resolved this T1, this resolved this T2 over here in cos and sine. Here it is horizontally. That's why I'm not resolving it. So can I say in this particular case, from the right side, this is the force. From the left side, this is the force. So I can say this is T2, we say cos of theta. And from this side, this is T1. From the upward, in the upward direction, we say, what is the force which is acting? That is T2 sine of theta. What is the force which is acting in the downward direction? That is mg. Now you can balance this. Now you can balance this. You can say in this particular case, we say T2 sine of theta is equal to m into g, because the block is not moving here. So net force is 0. Upward force is equal to downward force. This force is equal to that force. And then we say T2 cos of theta is equal to, we say T1. I hope this is crystal and clear to each and every single student. Guys, let me know in the chats if everything is crystal clear and sorted. Is this clear? Is this clear? Now guys, you have got this particular figure over here. You have to draw the FBD. We say draw the FBD of M1 mass, M2 and M3 respectively. You'll have to draw the FBD over here. Guys, see. First, if I talk about this M1, we say in the upward direction normal force is acting. Here on this one in the upward direction normal force N2 is acting. Here on this one normal force N3 is acting. Okay. And let's suppose this is the force F over here. In this direction there is force acting, something like this. Tell me one thing. Sir, if this is a rope, don't you think that in this rope tension we say T1 is acting? And here also tension will be, we say, sir, T1. Same tension, because a rope is same, tension is same. This is the same rope, T1, T1. Okay. And here it is away from the body. Here also it is away from the body. Here, you have got another rope. So here tension is T2 and here we say tension is T2. And here you have got force F. Let's suppose this force F is given at angle theta. Can I say this F we can resolve in, this will be F cos of theta, and here it is, we say F sine of theta, this component. Yes, sir. Sir, are there any more forces acting on these bodies? Yes. We say in the downward direction, it will be M1 into G. Here, it will be M2 into G. And here, it will be M3 into G. I guess these are the only forces. Acting on these three masses. Now see, if I make this mass M1 over here, draw the forces. In the upward direction, you have got N1. Okay. And in the downward direction, in this particular case, you have got M1 into G. And from the right side, you have got tension T1. Now let's make this mass over here. Okay. So we say this is M2. In the downward direction, you have got, we say, sir, M2G. And in the upward direction, you have got, we say, sir, N2. And from this side, you have got this tension T1. From this side, you have got this tension T2. Okay. And then if I make the third block over here, that is, we say, sir, M3. We say in the downward direction, it is M3 into G. We say in the upward direction, we say this is N3. And guys, one more thing I would want to add over here. What is that? If this, now this F has been resolved, forget about this. From the right side, we say here it is acting, that is F cos of theta. And from in the upward direction, you have got along with N3, you have got, we say F sine of theta. And from this side, you have got this force over here, that is T2. Okay. Where is theta? This is theta. This is theta. This is theta. Okay. So in this particular, sir, if you ask me, sir, shall we balance these three, these over here? We say will not balance. Why? Because of this force, it might be moving in the forward direction. So we'll have to use the Newton's second law over here. So we balance only in those cases where net force is zero. Yes, in the vertical direction, you can balance, because in the vertical direction, it is not moving. It is not doing the motion. Okay, this is the FBD. This is the final. Okay, this is the FBD over here. Is this clear? I'll show you how to write the equations over here in which block is moving. Please wait for some time. Please wait for some time. So till now, if everything is sorted, please let me know in the chats. And guys, hit the like button if you have not liked the session yet. I would want you guys to hit the like button. Everyone means everyone. Hit the like button, guys. Okay. Next. Equilibrium condition. Oh, it looks very small. What is equilibrium condition? Guys. If I say, if the net force on a body, is zero, it is said to be in equilibrium. It is said to be in equilibrium. Like, my dear friends, I have got a block over here. If I say on this block, I am applying the force F from the left side. And my friend is also applying the force F from the right side. Both the forces are equal. And another friend is applying the force from the upper side. Another friend is applying the force from the lower side. We say here, this force cancels with this force. This force cancels with this force. We say from all the sides, the forces are equal. So I can say here net force is zero. Net force is zero. Means the body is in the equilibrium. When net force on the body is zero, body is in the equilibrium. So I can say force in x direction, all the forces, summation of forces in the x direction, we say it is equal to zero. And all the forces, net forces in the y direction, that is also equal to zero. And all the forces in the z direction, that is also equal to zero. We say net force in x is zero, net force on y is zero, net force in z is zero. So I can clearly say the body is said to be in the equilibrium. If I say from now onwards, this is in the equilibrium, means the net force on this has to be zero, then only we can say this is in the equilibrium. Okay. Okay. Yes. We have got a question. What is the question? In this particular case, a block in the figure is shown is in the equilibrium. They are saying that the block is in the equilibrium, means it is not moving forward, it is not moving backward, it does not go up, it does not come down. Why? Because net force on it is zero and it is in the equilibrium. Then it says, find the tension in the block. We are supposed to find the tension in the rope. It has to write over here. Guys, see. We have to find the tension in these ropes. See, we have got this rope over here. We have got this rope over here. I can say, let's suppose tension in this rope is T1. And we have got another rope over here. I can say in this rope, tension is, let's suppose, T2. Because when the rope changes, okay, we say, tension will be different. Now guys, if I say this is what we call T2 and this is what we call T1. Now, here this angle is given as 37 degree. Don't you think that this will be also 37 degree? Why, sir? Because this angle and this angle are equal. We have studied this in the 8th class. Now, if this is T2, what is the force acting on this block? This will be, sir, that is T2 cos of 37 degree. T2 cos theta. And we say in the upward direction, what is the force? That is T2, we say sine of 37 degrees. Okay, it's another component will be in the upward direction. And what is the force in the downward direction? That is M into G. Mass is 30, G is 10. Okay. Now these are the forces acting on the body. We have to find the value of tension. Let's make the free body diagram over here. So we say we have got this block. Okay. So in the downward direction, what is the force? M into G. Mass is 30. G is 10. 30 into 10 is how much? That is 300. So we say in the downward direction 300 Newton. And what is the force in the upward direction? That is, I can write over here, that is T2. I'll write sine of 37 degrees. Sir, will there be not the normal force over here in this particular case? No. Why? Because the body is not in contact with any other body. So there is no normal force. That's why only T sine 37. And from the right side, what is the force acting? So that is T2, we say cos of 37 degrees. And from the left side, what is the force acting? Sir, that is, we say T1 over here. Okay. Now it is saying that the body is in the equilibrium. What does that mean? Net force is 0. What does that mean? That means upward force will be equal to the downward force. We say here, the block is in equilibrium. So I can say upward force is equal downward force. So I can write T2, I'll write sine of 37 degree is equal to, we say 300 Newton over here, because 300 is in the downward direction. Okay. Yes. Now what is the value of sine 37? Guys, if you remember, so many times I have told you about the 37 degree triangle and 53 degree triangle. If this is the 37 degree triangle, we know that this side will be 3, this will be 4, and this will be 5. And if I make over here the 53 degree triangle, we know in that case this will be 4, this will be 3, and this will be 5. Now, sine 37 is, sine is perpendicular upon hypotenuse, that is 3 by 5. So I can write over here, this is T2 and this will be 3 by 5 is equal to, we say, sir, 300. Okay. Now, 3 ones are, and this will be 300s are. Now here T2 will come out to be, that is 500 Newton. So value of T2 is 500 Newton. We got the value of this T2. Now we have to find the value of T1. Now can I say in this particular case, also, I can say this T1 is equal to, we say T2 cos of 37 degrees. Now T1 I can write, what is the value of T2? That is 500, and cos 37 is base upon hypotenuse, that is 4 by 5. Okay. 5 ones are, 5 hundreds are. Now 4 into 100 is 400. So T1 will come out to be, that is 400 Newton. Is this clear? T1 is 400, T2 is 500. I hope this is clear, and I hope you guys are loving this session. Okay. Is this clear? Everyone. Next. Next. Find the tension T2. Okay. We have got a system something like this. Find the tension T2 for the given system shown. We have to find this T2 tension. We can find all the tensions. No worries at all. No worries at all. We have got 1 kg block, we have got 2 kg block, and we have got 3 kg block. We have to find, guys, let me redraw the figure. It is something like this. We have got one block over here. We have got one more block over here. And we have got one more block over here. Yeah, this is the third block. This is given as 1 kg, this is given as 2 kg, and this is given as 3 kg. Now, in this particular case, guys, tell me one thing. We say, here, let me show you T1, T2, T3. Okay. Here we say in this rope, tension is T1. Here also tension is T1 because this is one rope. If the rope changes, we say tension will be different. So here tension is T2 and here also tension is T2. And here we say tension is T3. Here also we say tension is T3. Different tension. We have to find the value of T2. Guys, understand one thing very carefully. Let's take the third block over here. Let me show you the approach to solve these questions. Let me take the 3 kg block over here. We say in the downward direction, there will be M into G. M is 3 kg, G is 10. 3 into 10 is, we say, sir, 30 Newton. This is mg on this third block. Now take this third block. Guys, we say take 3 kg block. If I take this 3 kg block, if I make its FBD over here, so this is 3 kg. In the downward direction, it is 30 Newton. And in the upward direction, what is the force acting on this in the upward direction? So I say that is, we say T3 over here. Now, this block is not doing the motion. So we say it's in the equilibrium. Upward force has to be equal to the downward force. So I say here this T3 will be equal to 30 Newton. We got the value of T3. Now tell me one thing. If I have 2 kg block, we know that, sir, in the downward direction there will be M into G, that is 20 Newton. 2 into 10, M is 2 and G is 10. 2 into 10 is 20 Newton. Now make this FBD of, now take 2 kg block. Take this 2 kg block. Okay. So let me make it over here. This is 2 kg. So what is the force acting on the 2 kg in the downward direction? Sir, one is over here, T3, and one more over here is, that is 20 Newton. And in the upward direction, I can say that is, we say, sir, T2 over here. Can I say this T2 will be equal to 20 plus T3? Yes. So I can write over here T2 is equal to, I say, T3 plus 20 Newton. Yes. Now T2 is equal to, guys, upward force is equal to downward force. Why? Because this is in the equilibrium. Now what is the value of T3 over here? That is, sir, 30 Newton plus, we say, sir, 20 Newton will be equal to 60 Newton. Now let's suppose if somebody wants to find T1 also. Now I'll write over here, take 1 kg block. So this is the 1 kg block. Now tell me, on 1 kg block in the downward direction, there is mg. M is 1, G is 10. That will be 10 Newton. And there is T2 in the downward direction. In the upward direction, you have T1. So we say this is T2 and this is 10 Newton. In the upward direction, I can say this is T1. So here I can write T1 will be equal to this force plus this force, that is T2 plus, we say, 10 Newton. So T1 will be equal to, what is the value of T2? T2 we recently got as 60 Newton plus, that is we say 10 Newton. So T1 will come out to be, that is 70 Newton. Okay, okay. This is 50. This is 50. Okay, sorry. 30 plus 20 is 50. I thought it was 60, huh? When did it change? Recently? Okay. So we say now over here we say it will be 50 plus 10 Newton. So this will be 60 Newton. This will be 60 Newton. Okay. Great. So basically, my dear friends, this is how we can solve this particular problem. Next. Okay. Before this, I would want you guys to exactly focus on one single concept. That is Newton's third law of motion. Newton's third law of motion. Let me talk about the Newton's third law of motion. Okay. Everyone over here. Yes. Guys, see. What is Newton's third law of motion? It says that for every action, there is equal and opposite reaction. For every action, there is equal and opposite reaction. Okay. That is what we call the Newton's third law of motion. What do we say? It says that, guys, see. Let's suppose I have got a block over here. Okay. I have got a block over here. And I am applying the force on this particular block. Let's suppose F. If I am applying the force on this block is also applying the same force on me, that is F. To every action, there is equal and opposite reaction. Example, real life example is, let's suppose I have got a table over here. On this table, I have placed a block. Can you tell me what is the force on the block because of the table, sir? That is normal force. So table will apply the force on this block, that is N. Now could you please tell me, will this block also apply the force on the table? We say, sir, yes. What is that? That is also normal force. So I'll show that something like this. So this is N dash. Sir, this N is equal to N dash. Both will be equal over here. So this, if block is applying the, if table is applying the force on block, the block is also applying the force on table. So this is N and N dash. Okay. That's what we call the equal and opposite reaction. They are equal, they are opposite in direction. So forces always exist in pairs. So we say this one and this one over here. So they are in pairs. If this is normal, this is normal. Okay. Now, if you ask me, sir, why do not they cancel each other? The reason is because these two forces are acting on the two different bodies. So when force acts on two different bodies, they do not cancel each other. But if the force, if let's suppose you have got a block over here, you are applying the force, you are applying this and this will cancel. But if the two forces, if this is one force and this is another body, this is the force on this body, this and this will not cancel over here. So we say, these two, this action-reaction pair, this is what we call the action-reaction pair, This action-reaction pair acts on two different bodies. It does not act on the same body. Okay. So what is the another force which is acting on this one? Sir, that is mg. So we say mg and n are not the action-reaction pair. No. They are acting on the same body. But n and n dash are the action-reaction pair. They should have the same nature. This is gravitational force. This is normal force. They have the different nature. So this n dash and n, we say n and n dash are action-reaction. Reaction. To every action, there is equal and opposite reaction. To every action, there is equal and opposite reaction. To every action, there is equal and opposite reaction. Next, Now guys, here all the details are mentioned. We say they must act on different bodies. As I told you, if I am applying the force on this board, the board is also applying the force on me. So I am applying on board, board is applying on me. Force on two different bodies. They must be of the same nature. Okay. If I am applying the normal force, board will also apply the normal force. That is called action reaction. They must be equal in magnitude. If I am applying 10 Newton, board will be also applying 10 Newton on me. They will be equal in magnitude. They must act simultaneously. So if I am applying force right now, it is not like the board will apply force on me tomorrow. No, it is simultaneously. Okay, both the bodies apply force on each other at the same time, simultaneously. Okay, they must be acting in the opposite direction. The direction, if I am applying in the inward direction, board is applying on me in the outward direction. Guys, please tell me in the chats if everything is crystal and clear and sorted. I would want all of you to tell me in the chats, okay? And one more thing is, hit the like button as soon as possible. Okay, okay. Liking the session is extremely mandatory. So we are done with the Newton's third law of motion also. Now let's come back onto the topic. Let's come back onto the topic. This is free body diagram. Okay, this was the topic. Is this clear? Great, great, great. Now guys, Axle application of F is equal to mass into acceleration. Application. Now we'll be basically using the F is equal to ma in variety of questions out there. We'll be using F is equal to mass into acceleration in variety of questions out there. Okay. So take a chill pill. So let's basically solve the questions over here. Let's suppose I have got a mass of 5 kg over here and 20 Newton force is acting. I'm saying find the acceleration of the mass Guys, we know that force is equal to mass into acceleration. Whenever you apply the force on any body, we say acceleration will come. And here we can say this acceleration is simply force divided by mass. And what is the value of this force over here? That is 20 Newton. What is the value of mass over here? That is 5. 5 into 4, that is 4 meter per second square is the acceleration of the block. Okay. Let me give you one more. Let's suppose I have got a block over here. I am applying over here, this is F is equal. From this side, I am applying 2 Newton. Let's suppose 20 Newton force. And from this side, it is acting 10 Newton force. And mass over here is 2 kgs. I say find acceleration of the block. Find the acceleration. Find the acceleration of the block. Guys, always remember, when it comes to the acceleration, we say this acceleration is net force divided by mass. Because what is the actual formula? This is F net is equal to mass into acceleration. F net is equal to mass into acceleration. So I can write over here acceleration is equal to, what is net force? The net force will be 20 minus 10. Bigger minus smaller. 20 minus 10. 20 minus 10 divided by. Mass here is 2. So 20 minus 10 is, we say, sir, 10 divided by 2. That is 5 meter per second square. I hope this is also sorted. This is also crystal and clear. Yes. Next. Let's take a look at this particular question that we have exactly over here. Find the acceleration and force by the floor on the block. Okay, we have to find the acceleration and guys, this is the floor over here. This is the floor over here. Okay. We said this floor is applying the normal force on this block. And on this block in the downward direction, there is mg. We have to find the value of n. We have to find the acceleration of the block. Okay. We have to find the acceleration of the block. We have to find the normal reaction. Understand one thing. Guys, let's first see forces on the block. Let's first draw forces. If this is 50 Newton, this is 37. Don't you think that this will be 50? We say it is cos of 37 degrees. Yes. And in the upward direction, this will be, I say 50 sine of 37 degrees. Yes. Whenever you have to solve the questions of this type, the very first thing is you guys make the FBD of that question. You guys make the FBD of that question. Now, if I take the block over here, okay. Now make the FBD. What is the force from the right side? Sir, force from the right side is, that is 50, we say cos of 37. What is the force from this? Okay, this is also the force from this side only. Let me make it from this side. But the direction of the force is this. Guys, direction of the force is same. So we say this is 20 Newton. This and this are in the same direction. So they'll add up. Okay. And in the upward direction, you have got, that is 50 sine of 37. And you have got normal force. In the downward direction, you have got mg. You have got mg. Okay. So these are the forces acting in on the block. So in order to solve the problems, what is the first thing you guys are supposed to do? Make the FBD. And how can you make FBD? Draw all the forces acting on the block. That is done. Now we'll make the FBD. Guys, let's take, we say along y direction. Along y direction. I would want all of you to focus over here. Y direction means this, vertical direction. This is x direction. Is this block doing the motion along y direction or x direction? Sir, obviously x direction, not y direction. So if y direction, we say along y direction, the block is not performing the motion. So means along y it is in the equilibrium, not along x. Along y it is in the equilibrium. So can I say in that case, that is n plus this force will be equal to mg. N plus 50, we say sine of 37 will be equal to, we say m into g. 100% sir, 100% sir. So can I write over here, guys? We say this is n. Then we say plus, this is 50. What is the value of sine 37? What is the value of sine 37? That is perpendicular upon hypotenuse. Guys, sine 37, take a look at this triangle over here. What is the value of sine 37 from this triangle? Perpendicular upon hypotenuse, that is 3 by 5. That is 3 by 5. So I'll write over here, this is 3 by 5 is equal to mg, is equal to mg. Is equal to mg. M is the mass. Mass is how much? That is given as 5 kgs. So this will be 5 into 10, that is 50 Newton. So 5 ones are, 5 tens are. Now this is 10 into 3 is 30. So N will be, take this 30 over there, 50 minus 30 will come out to be 20 Newton. So value of normal force we got as 20 Newton. Now we have to find the acceleration of the block. Okay. Now we have to find the acceleration of the block. Now we have to find the acceleration of the block. Just a second. I'm looking for some good color over here. Now, now we say acceleration of the block. Guys. In order to find the acceleration, we say acceleration is equal to net force divided by net mass. Divided by mass. Now. If you take a look at the horizontal direction, what is the net force? Sir, this force plus this force, both are in the same direction. So I can write acceleration over here is, that is 50 cos of 37. Okay. So I'll write that is 50 cos of 37 plus we say this 20 divided by what is the mass? Mass is, we say, sir, 5. Done and dusted with the question. Okay. Done and dusted with the question. Now 50 cos 37 is 4 by 5. Guys, I can solve this. This is 50 into 4 by 5. 5 ones are 5. 5 ones are 5 tens are 50. Now this will come out to be, that is 40. So this is its value is 40. So it will be 50 cos 37 is 40 plus 20 is how much? That is 60 divided by 5. Okay. So that will come out to be, so acceleration will come out to be, that is 12 meter per second square. 12 meter per second square. Guys, tell me in the chats, how many of you are understanding this? Along y direction, we are balancing the forces. Along x direction, we are using the Newton's second law. Why? Because along x direction, it is not at rest, it is moving, it is in motion. That's why acceleration is net force is equal to mass into acceleration. You cannot balance these two over here, but you have to use Newton's second law. Guys, hit the like button. Everybody of you, mark the attendance. Next. Okay. Next, let's suppose if you get a question something like this. Guys, if you ever get a question something like this, this is what we call motion of a connected mass system. Motion of a connected mass system. If you ever get a question something like this, motion of a connected mass system. And if they ask you to find the acceleration, we say find acceleration here. They would ask you to find the acceleration over here. I would recommend you one single thing. I would recommend you one single thing in this particular case. What is that? Guys, see. In order to find the acceleration in this particular system, what you are supposed to do is directly remember the formula. Acceleration will be, we say net pulling force. Net pulling force upon, we say, net mass. Net pulling force upon net mass. I would want you guys to remember it directly over here. What is the net pulling force? I'll tell you. How much is this mass over here? Guys, we say 5 kg. We say in the downward direction, mg is acting. And what is the value of that mg? That is 5 into 10. M into G. So that is 50 Newton. What is the force on this in the downward direction? That is M into G. That is 3 into 10. That is 30 Newton. And on this also downward direction is mg and upward is n. So that will get cancelled out because it is placed on this surface. Okay. Now here in this entire system, the pulling forces are this one and this one. Because these two forces are called the pulling, because they are pulling the blocks, they are pulling the system. And when it comes to the tension over here, this will be tension T1 and here also tension T1. Here also tension T1, here also tension T1 because string is same. Sir, shall we consider these forces also in the pulling force? No. These are the internal forces of the system. We do not consider it. And here tension is T2. And here also it is T2, here also it is T2. Now, let me write the acceleration. So I'll write acceleration over here. Net pulling force. How much is the net pulling force? See, this is a downward, we say, sir, 50. And this is over here, we say from the another side, it is 30. Now, guys, see. Do it like this. Elongate this something like this. So it will be, this is first block, this is the middle block, and this is this block. Now, on this block, 5 kg block, 5 Newton is acting over here. And on this 3 kg block, this will be, sir, 30 Newton in the backside. Now, tell me how much is the net pulling force. 5 Newton is forward, 30 Newton is backward. So it is not 5, it is 50 Newton. So 50 minus 30. 50 minus 30. So net pulling force is 50 Newton minus 30 Newton. It is greater minus smaller. Divided by net mass. What is the net mass of the system? 5 plus 2 plus 3. That will be 10. So this is 20 divided by 10. So it will come out to be 2 meter per second square. Is this clear? Is this clear? I would want you guys to tell me in the chats, is this clear? Is this clear? Is this clear? Is this clear, everybody, guys? Great. Okay. Let's suppose in the same question they ask you to find the tension also. Also find T1 and T2. Also find T1 and T2. If they ask you to find the tension also in the same question, what you are supposed to do in that particular case? Guys, see, let's first find T1. So we say take we say 5 kg block. Guys, first you find the acceleration, net force upon net mass. Then if they ask you to find the tension also, then take 5 kg block. I'll take this 5 kg block over here. This is the 5 kg block. And draw the forces on it. We say, sir, in the downward direction, it is 15 Newton. In the upward direction, it is tension T1. Okay. Now, guys, this is 50 Newton. This is 30 Newton. Obviously, this force is greater than this. So the system will go something like this. This will pull more. Okay. Now, we can say in this particular case, this will be the acceleration of the block. Because 50 is greater than 30. Now, we say use Newton's second law. Okay, what is that? That is net force is equal to mass into acceleration. Guys, see, I say what is net force? Net force is greater force minus smaller force, this minus this. So I say that will be 50 minus T1 is equal to mass into acceleration. Mass of this is 5 kgs. So I say that is 5 and what is the acceleration? Guys, whatever is the acceleration of the entire system, 2 meter per second square, same will be the acceleration of this, same will be the acceleration of this, same will be the acceleration of this. So that is 5 into 2, that is 10. Now take it over there. This is 50 minus, take it over here, that is 10 is equal to T1. 50 minus 10 is 40 Newton is equal to T1. So value of tension T1 is 40 Newton. Is this clear? Is this clear? Please tell me in the chats. So first you find the acceleration in such type of questions, that is net pulling force upon net mass. And then if they ask you to find tension T1 and T2, you can take the blocks individually then and apply the Newton's second law. Let's find T2. Let's find T2. Guys, see. I'll write over here. Now take we say 3 kg block. Take 3 kg block. So this is the 3 kg block. We say in the downward direction, how much force is acting? 30 Newton. In the upward direction, how much force is acting? That is T2. Okay. And if you take a look at the entire system, we say this force is more. So it is going up. The block is going up. So I can write this force will be more. So this is the acceleration over here. Okay. Can I use the Newton's second law? We say, sir, net force is equal to mass into acceleration. Net force will be greater minus smaller. If it is going up, obviously T2 will be greater than 30. So I can say this will be T2 minus I can say 30 is equal to mass into acceleration. Mass is 3 kg, acceleration is 2. Now T2 will be 3 into 2 is 6. Take it over there. 30 plus 6. This will go over here. 30 plus 6 is this will be 36 Newton. This will be 36 Newton. So T2, value of T2 in this particular case came out to be that is 36 Newton. Okay. This question, now it looks easy. Now this looks easy for us. Find the tension and acceleration. You will solve it within a fraction of seconds. How to find acceleration, sir? When it comes to the acceleration, we say net pulling force. And then we say upon, I'll write over here net mass. Net pulling force upon net mass. Okay. So I can write over here acceleration is net pulling force. What is the net pulling force in this case? Guys, see, this is 3 kg. In the downward direction, it will be 30 Newton. 3 into 10. M into G, 30 Newton. And here it will be, we say, sir, 20 Newton. Okay. What is net pulling force? 30 minus 20. So I can write over here, this is 30 minus 20 divided by net mass. That is 3 plus 2 and that is 5. So 30 minus 20 is how much? We say, sir, this is 10 by 5. That is 2 meter per second square. So acceleration in this case came out to be, we say 2 meter per second square. Okay. Now let's find the tension. Guys, we say here tension is T1. Let's suppose it is T, here it is T. It is the same rope. The rope is same because it is one pulley. So here it will be T, here also it will be T. Now, in order to find the tension, take any of the blocks. So we say to find tension. So can I do one thing over here? What is that? Let's take this block. We say, let's take this 3 kg block. In the downward direction, this is, we say, sir, 30 Newton. In the upward direction, this is the tension. Okay. Now tell me one thing, guys. 30, it is going down. So this force will be greater than tension. So use F is net force is equal to mass into acceleration. What is net force? 30 minus T. You'll say, sir, this is 30 Newton minus T is equal mass into acceleration. Sir, mass is, we say, sir, 3. Acceleration is how much? That is 2. Now tell me, take it over there. So this will be 30 minus 3 into 2 is 6. Take it over there. 6 is equal to, we say, T. So T will come out to be 24 Newton. T will come out to be 24 Newton. Is that clear? Three into 2 is 6. We say always net force is equal to mass into acceleration. This is in the downward direction, it is 30. In the upward direction, it is T. So if acceleration is this, if the block is going down, we say 30 will be greater than T. So bigger force minus smaller force. So that is what we call net is equal to mass into acceleration. Now 3 into 2 is 6. Take it over there. 30 minus 6 is equal to T. T will come out to be 24 Newton. Hey, is it clear? Guys, let me know in the chats Everybody, is this clear? I would want everybody of you to tell me in the chats, is this clear? And make sure you hit the like button. Everybody, mark the attendance. Marking the attendance is extremely mandatory. Okay, now, now, let's suppose you have a question. Guys, we'll have to go. It is only 8:34 right now. We'll be going till 9 o'clock or 9:15, something like that. 9 to 9:15, we'll be finishing this one. Find the acceleration of the block. Okay. Force between 2 kg and 3 kg block. Find the force between 3 kg and 5 kg block. Okay, okay. First, find the acceleration of the system. I'll write over here. Okay. Guys, when it comes to the acceleration, I told you acceleration is, we say, net force upon, we say, net mass. So I'll write over here, acceleration is simply, what is the net force over here? Net pulling force, net pulling force, net pulling force. Okay. Now guys, see, this over here, this force and this force. Guys, whatever is the external force, be it pulling or extra, see here you have to take these. Now this is 40 minus 10. So external, this is greater than 10. So I'll write 40 minus 10 divided by net mass. This and this. In case of connected system with the pulleys, over there it will be pulling, here it is the net external force. So I can say that will be net mass is 5 plus 3 is 8, 8 plus 2 is, we say, sir, 10. So this will be 40 minus 10 is, that is 30 divided by 10 will come out to be 3 meter per second square. So acceleration of this entire system is 3 meter per second square. Acceleration of the entire system is 3 meter per second square. Now guys, listen to me very, very, very carefully. If the acceleration of the entire system is 3 meter per second square, means this will have the same acceleration, this will also 3 meter per second square, this will also have 3 meter per second square. Okay. Now we have to find the force between 2 kg and 3 kg block. 2 kg and 3 kg. Guys, see. I'll make the figure over here. This is, let's suppose, 2 kg. And this is, let's suppose, 3 kg. I would want you guys to listen to me very carefully. We say, this will apply the normal force on this one. Let's call that N1. This will apply the normal force on this one. That will be also N1. Because we know that if this applies 10 Newton on this one, this will also apply 10 Newton. But the direction will be opposite. And these two normal forces are acting on the two different bodies. Okay. We have to find force between these two. Let's find this N1 in this particular case. Okay. Let's find this N1 in this particular case. Guys, see. We say, let's take this block. And what is the force on this 2 kg block? That is 40 Newton over here. Okay. We have to find N1. Guys, see, we say as take, we say 3 kg. What is the mass of this one? 2 kg. The mass of this one is 2 kg. We say 2 kg block. Take 2 kg block. Let's take this 2 kg block. Okay. If I am taking the 2 kg block over here, and this was the third block connected to this one. Okay. So we say, if I'm taking 2 kg, what are the forces acting on 2 kg? Guys, see, we say, sir, this will be over here, that is 40. Okay. And this will be, sir, N1. Okay. And we say acceleration of this block is, guys, we recently calculated acceleration of the entire system is 3. So this block will also have acceleration of 3 meter per second square. Now guys, understand one thing very, very, very carefully. Understand one thing very, very, very carefully. Use Newton's second law. We say net force is equal to mass into acceleration. In this case, net force is equal to mass into acceleration. What is net force over here? Sir, this force minus this force, okay, because this is in the motion. That's why we are using this second law. So that is 40 minus this force, that is N1. They are opposite, is equal to mass into acceleration. Mass is 2 kgs. So that is 2. Acceleration is 3 over here. Now guys, I can write this as 40 and take it to 2 into 3 is 6 minus 6 is equal to N1. 40 minus 6 is how much? That is 36. So N1 will come out to be 36 Newton. This is the value of N1. And this is the force between 2 kg block and 3 kg block, that is N1. If this is applying 36, this is also applying 36 Newton to the other block. Now, force between this block, bigger block, and this one. See, force between 5 kg and 3 kg, 3 kg and 5 kg. Now guys, I say, if this 5 kg, this is 5 kgs, okay, and this is 3 kgs. We said this, if this is applying on this normal force as N2, we know this is also in contact with this one, so this will also apply the normal force as N2. Okay. And what is the force on this one? Force on this 5 kg block is 10 Newton from this side. So I can say here it is 10 Newton. Now, take this block. Now, we say take 5 kg block, 5 kg block. I would want you guys to take this 5 kg block. So can you use over here once again, we say net force is equal to mass into acceleration. Guys, this is 5 kg block. On this 5 kg block, we say in this direction 10 Newton is acting. What is acting on the another side? That is this N2. So we say this is N2 is acting from the another side. Okay. Now, if this was the 40 Newton, means block is accelerating in this direction, So here, which one is greater? Obviously, N2 is greater than this, because this is the acceleration over here, that is 2 meter per second square. So whatever is the direction of acceleration, same will be the direction of net force. So here net force is N2 minus we say 10 is equal to mass into acceleration. Mass is 5, acceleration is 2. Now N2 will come out to be 5 into 2 is 10. Okay, 5 into 2 is, we say sir, 10. What is the acceleration of this block? Acceleration is 3. Sorry. Acceleration is 3 meter per second square. Okay, 3 meter per second square. So 5 into 3 is 15. So it will be 15 plus this, it is minus 10, it will go over there, that is plus 10. So N2 will come out to be 25 Newton. Is this clear? Is this clear? Guys, I would want you to tell me, is this clear? Is this clear? Is this clear? So this is basically the answer to all the 3 questions. All the 3 questions. Okay. So we say force between 2 kg and 3 kg, force between 3 kg and 5 kg. Okay. Next. This question I'll give you as the homework now. Okay, it is based on the same format. So acceleration, find the acceleration of the block. Acceleration is easy. Also find the force Find the force between, we say, 3 kg and 4 kg. 3 kg and 4 kg. Also, between 4 kg and 2 kg and 2 kg. Guys, this is the question that I'm giving you over here, and I would want you guys to solve it and let me know the answer of this question in the comments. Answer of this question I would need in the comments later on. Okay? Answer of this particular question I would need in the comments later on. Now. Next. This. Find the tension T2 in the string. Okay? Find the tension T2 in the string. This is the 40 Newton force pulling this entire system, 4 kg mass, 6 kg mass and 10 kg mass. So it will be going something like this. So we have to find this tension T2 and we'll find the tension T1 also. No problem at all. No problem at all. I would want you guys to focus exactly over here. All the people. Guys, see. Let's first find the acceleration. Let's find the acceleration of the system. Let's find the acceleration of the system. Guys, okay? Now, when it comes to the acceleration of the system, we say acceleration is net pulling force upon net mass. We say net pulling force. Net pulling force upon, we say, net mass. Net pulling force upon net mass. What is the net pulling force? That is only 40 Newton. These are the internal forces. We don't consider these in the pulling force. So I can say acceleration in this case is net pulling force is 40 upon net mass of the system is how much? 4 plus 6 plus 10. That will be 20. That will be 20. This and this will cancel. This will come out to be 2 meter per second square. So acceleration of this system is 2 meter per second square. Okay. Now, let's find the tension T2. Now, I'll write over here, take, we say 4 kg mass. I would want you guys to take the 4 kg mass exactly over here. I would want you guys to take this 4 kg mass exactly over here. So this is the 4 kg mass. We say in the forward direction 40 Newton is acting and we say in this direction T2 force is acting. This is the tension over here. And it is accelerating in this direction. The acceleration is 2 meter per second square. Guys, whatever is the acceleration of the entire system, same will be the acceleration of this block and this block. Now tell me in this particular case, can I say, sir, net force is equal to mass into acceleration, What is net force? 40 minus T2 because it is moving in this direction. So I'll write that is 40 minus, we say, T2 is equal to mass into acceleration. Its mass is how much? That is 4. And acceleration is how much? That is 2. Okay. Now we say this is 40 minus 4 into 2 is how much? That is 8. So take it over there. 40 minus 8 is, we say, T2. So T2 will come out to be, that is 32 Newton. T2 is coming out to be 42 Newton. Okay. That is 32 Newton. Is this clear? Is this clear? Is this clear? Is this clear? Everyone, guys, let me know in the chats. Let me know in the chats if this is crystalline clear. Now, let's take this block, okay? I'll write over here. Now, take, we say, 10 kg block. 10 kg block to find we say T1. Let's take 10 kg block to find T1. So if I am taking 10 kg block over here, okay, if I'm taking 10 kg block exactly over here, okay, so we say this is, we say in this particular case T1, okay, and my dear friends, this has got 10 kg mass. I can write simply over here net force is equal to mass into acceleration. So we say acceleration of this block is also, that is 2 meter per second square. So what is the net force on this block individually? That is T1. So we say T1 is equal, there is no other force acting, is equal to mass into acceleration. Mass is 10, acceleration is 2. So 2 into 10 is, we say, sir, this is 20 Newton. This is 20 Newton. Vasu, I would recommend you one thing over here. Ignore the chats and directly close the chats right now and focus on this one and then solve the questions. That's the reason you are getting the wrong answer. That's the reason you are getting the wrong answer. So I would recommend you to close the chats and then focus on this one and then answer, then solve it, and don't answer in the chats. Just keep on solving the question. Just keep on solving the question. That's it. Okay. Is this clear? Is this clear? I hope everything is sorted now. I hope everything is sorted now. Now guys, next we have this pulley system over here. Next we have this pulley system over here. See guys, what is this pulley system over here? See, if we have this pulley system over here, pulley means, let's suppose I have got, you might have seen the pulleys in lot of questions out there. You might have seen the pulley in lot of questions out there. Let's suppose I have got over here a structure something like this. Guys, let's suppose I have got a structure something, this is a ceiling, and I am connecting a rope to this one, okay? I'm connecting a rope to this one, and there is this pulley. And now, in this particular case, there is one block attached to this pulley, and there is one more block attached to this pulley, okay? Since you guys know that, guys, listen to me very carefully. If we have got a pulley over here, so this is one rope over here, and this is, we say, tension T1. Here also tension T1. So the rope is same, so this is tension T1, and this is also tension T1. Okay. Now, if this is one rope and this is the another rope over here, so we say in this one it is tension T2. It is tension T2. Same I have mentioned over here. Guys, I say this has got in this particular case, in the upward direction, I'm saying tension T dash. Let's suppose this is T dash, and this T1 is T, and this will be also obviously T. This is T, and this is T dash. Okay. Now tell me one thing in this particular case. Let's suppose this entire system has got, is it at rest or is it, we say, accelerating? We say, sir, it is not accelerating, it is at rest. So can I say acceleration of this entire system is 0 over here? Because it is not moving over here. This pulley, acceleration of the pulley, we say acceleration here, acceleration of the pulley is 0. I say acceleration of the pulley is 0. Now guys, use Newton's second law. Use Newton's second law. I would want you guys to focus over here. What does Newton's second law say? Sir, Newton's second law says that net force is equal to mass into acceleration. We say net force is equal to mass into acceleration. What is net force? Guys, see, net force here will be this T dash minus, in the upward direction, how much is the force? T dash. In the downward direction, how much is the force? T plus T, that is 2T. So you can say that is T dash minus 2T. Sir, why not 2T minus T dash? Do that also. It's one and the same thing because acceleration is 0 over here. Is equal to mass of the pulley and acceleration of this is, let's suppose, 0. Okay. In this particular case. Now, I am saying that in this particular case, we say, if in any case acceleration of the pulley is over there, no problem, you can mention the acceleration. But when it comes to the mass of the pulley, all these pulleys that we take in our syllabus is the massless pulley. Okay. All these pulleys that we take in our syllabus are we say massless pulleys out there. Now, if these are massless, we say then it will be 0 into, we say, sir, acceleration. Here, if I say acceleration of the system is 0, then it will be 0. If in any case it has got the acceleration, we say, sir, this pulley I am considering. So I can say in this particular case, sir, this T minus 2T, T dash minus 2T will come out to be 0. Take it over there. So T dash will come out to be 2T. So what I am trying to say is that in case of these pulleys, guys, I say upward force, this tension will always be equal to this tension plus this tension. Remember it directly. This is the proof over here. In our syllabus, we consider the ideal pulleys, which are massless and frictionless. We consider massless, means we don't consider the mass of these pulleys. If mass is 0, we say this will be 0. So directly from now onwards, guys, from now onwards, if I say I have got a pulley over here, so this is tension T dash and this is in the downward direction. Let's suppose this is 5 Newton, this is 5 Newton. Can I say this force plus this force is equal to T dash? So I say T dash here will be 5 plus 5, that is equal to 10 Newton. What is the value of T dash over here? Here, upward force is equal to downward force. So here also it will be 10 plus 10, that is 20. What is the value of T dash here? T dash here is this force plus this force. Okay. That is 20 plus 20, that is 40 Newton. Is this clear? Please tell me in the chats. Everybody, guys, let me know in the chats if this is crystalline clear. If this is clear. Now, let's take a look over here. Find T1, T2 and T3. You have got this particular system over here. Guys, see. I'll make you understand. You have to find tension T1, T2 and T3. Understand very carefully. See. The very first thing over here is, I told you that, see, if this is the 5 kg block, we say on this 5 kg block in the downward direction, mg will act. How much is that? That is 5 into 10, that will be 50 Newton. 5 into 10, that will be 50 Newton. In the downward direction, we say it is 50 Newton. Okay. Now, if this is 50 Newton, and guys, we say here it is tension T1 in the rope. And same tension will be over here. Guys, see. Let's first find T1. So as we say block 5 kg is in equilibrium. So can I say upward force is equal to downward force? So I can say here T1 will be equal to, that is 50 Newton. T1 will be equal to 50 Newton. Upward force is equal to downward force. T1 will be equal to 50 Newton. Okay. Now guys, if T1 is 50 Newton, understand very carefully. I'll make a pulley over here. We say if this tension T1, this is over here 50 Newton. We say same tension will be over here also. This is also 50 Newton. Yes, sir. And you have got this over here, that is T2. Now, recently I told you when it comes to this, upward tension, it will be equal to this tension plus this tension. So can you tell me here, what is the value of T2? That is 50 plus, we say, sir, 50, and that comes out to be 100 Newton. 50 plus 50 is 100 Newton. Okay. Now, once we are done with this one, so value of T2 came out to be 100. Now make this pulley. Now make this pulley. So I'll make this pulley right now. So here this tension is T2. I'm making this tension over here as T2. Okay. So if you go over here, here also it will be T2. And here in the upward direction, it is T3 over here. So we say here also it is T2 and this will be, sir, T3. Don't you think that this T3, what is the value of T2? That is 100 and value of this is also 100. Don't you think that this T3 will be equal to this plus this, that will be 200 Newton. So this is the value. This is how we can solve the questions of this format. Is this clear? Is this clear? Please tell me in the chats. Everybody out there, guys, is this clear? So T3 is 200, T2 is 100 and T1 is 50 Newton. T1 is 50 Newton. I guess it is clear to each and every single student. I guess this is clear to each and every single student. Can you solve this particular question? Can you solve this particular question? Find the force applied by the man to hold the block. Okay, how much force is applying to hold the block? Okay, we have to find the value of tension. To find tension over here, to find tension. Guys, find tension T in this particular case. See, guys, if this person is holding this over here, what will be the value of tension over here? Sir, it is T. Here also it is T. Now, understand very carefully in this particular case. If this is T, we say the same will go over here, this is T. If this is T, same tension will go over here, that is T. Now, same tension will go over here, that is T. Okay, let me redraw it. If this is T over here, here also it is T. Here also it is T. Here also it is T. Because it is the same string. Here also it is T. Here also it is T and here also it is T. It is the same string. Now, how many T's are over here? 1 T, 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 T. 1, 2, 3, 4, 5, 6. 6 T. Okay. Now, guys, tell me one thing. Tell me one thing in this particular case. Tell me one thing in this particular case. See, when it comes to this particular block, there are further two pulleys which is connected to this one and this one. Guys, understand very carefully. If this is a pulley, this is T, this is T, what will be the value of this tension? Obviously, it will be 2T. T plus T is 2T. Now, take this pulley. Here, this is T, here, this is T. What will be the value of this tension over here? This is also 2T. And here it will be T. Now, this is the block. Now, guys, we say, I'll take a block over here. And this is the 10 kg block. In the downward direction, how much is the force acting? M into G. That will be 100 Newton. In the upward direction, what are the forces acting? Guys, in the upward direction, the forces are acting. This 2T, okay, this will be the direction over here. And this 2T, and we say this T. 2T plus T is 5T. So I say over here 5T is equal to, we say 100. T will be 100 by 5, that is 20 Newtons. 100 by 5, that is 20 Newtons. Guys, see, we have got a rope over here. Tension in this rope is T. Here also tension will be same T. Same rope T, same rope T, same rope T, same rope T. Now further there are two pulleys. If this is T, this is T. T plus T, that is 2T. So this will be equal to this tension, that is 2T. So here also 2T, here also T. Guys, is this clear? Is this clear? The answer is 20 Newton in this particular case. Is this clear? I would want you guys to tell me in the chats if this is crystalline clear to each and every single student. Let me know. Everyone means everyone. Now. Spring force. Let's move on to this particular topic, that is spring force. What is the spring force all about? Guys, see, what is the spring force all about? Let's suppose you have got a spring over here and you have connected a block to this particular spring in this particular case. Okay. And I am saying that we say apply a force on this particular block. We say external force. Okay. You elongate this spring till over here. You elongate this spring till over here. Can I make it something like this? Guys, I'll make it something like this. So it will be something like this. Okay. Spring will be elongated. Okay. Tell me one thing. Have you ever observed that? If we elongate a spring in this direction, if we displace it, guys, initially it was over here. If we displace it by X amount, don't you think that this spring will try to pull the block back? And the force which the spring apply over here to pull the block back is what we call the restoring force. We say if we elongate the spring towards right. If we elongate the spring towards right, the spring will try to bring the block back. With the force, or restoring force called spring force. Okay. So whatever the force the spring will apply over here to get the block back, that is what we call the spring force. This is the force which is generated in the spring over here. And guys, we say this spring force is equal to, that is, minus k times of x. Okay. It is basically like this. The more you elongate the block, the more you elongate the spring, the more it will pull it towards this. So we say F is directly proportional to X. If you displace the block more, spring force will be more. Okay. And we say replace this proportionality with a constant. So I'll write minus k times of X. Sir, why this minus? This minus is because if you displace the block towards right, force will be to its opposite. Force will be towards left. That's why we say F is equal to minus k times of X. Okay. Where k is called the spring constant. K is the spring constant. Okay. So K basically tells you the stiffness of the spring. K tells us stiffness of the spring. Means how much force we need to apply to elongate the spring depends upon K. Okay. That is what we call the spring constant. So directly this will be the value of spring force over here, or we also call it the restoring force. Okay. Now guys, what are the pattern of questions that they can ask in this particular case? See. Find the reading of the spring balance and the extension in the spring. Let me tell you what is the extension in the spring. Guys, see. I say this is a block attached to the spring. How you can solve the questions in this particular case, I'll tell you. If you have got a block over here, we say on this block in the downward direction, mg force will act. Now, don't you think that because of this mg, the spring will elongate? Yes. So what will be the force in the spring? You say, sir, force in the spring will be towards itself, opposite to the displacement. That will be F is equal to K times of X, or minus, ignore the negative sign over here. So K times of X, in the downward direction, it is mg. Guys, if let's suppose because of this mg, it has elongated and now it is in the equilibrium. What is the force in the upward direction? We know, sir, it is K times of. If you remove this force, it will go back to the original position. We say at equilibrium. Don't you think that upward force is equal to downward force? Yes. So we say K times of X is equal to, we say, sir, mg. So directly you can find X will be mg divided by K. So from now onwards, you will remember that. If they ask you to find the extension in the spring, how much spring has extended over there, you can simply say that is mg divided by K. That is mg divided by K. Okay, let's suppose if they ask you the question something like this. Okay, find the extension in the spring over here. Find the extension. This is the spring. This is the spring. This is the spring over here. You have to find the extension in the spring. Find X. Find X. Guys, see. Wait for me, please. I say I have got a block over here. We say on this block in the downward direction, force will act, that is 50 Newton, M into G, okay? And here it will be tension, that is T. Now guys, see, this rope is fixed over here. It will not go up and down. This block cannot go up and down. We say block is in equilibrium. Block is in equilibrium. So if block is in equilibrium, can I say upward force is equal to downward force? Yes. So I can say tension will be equal to, that is simply 50 Newton. If this is at rest, block is in equilibrium, upward force is equal to downward force. Now guys, if you have got tension over here, here also it will be tension away from the pulley. Now go. Here also it will be tension away from the pulley. Now, I would want you guys to focus over here. Now take the pulley. Now take the pulley. If you take the pulley over here, guys, see. We say you have got this pulley. You have got this pulley. Sir, and there is a spring over here. Just a second. You have got this pulley. There is a spring over here. Okay. And here you have got tension. Here you have got tension. This is T and this is T. T and T. Now. This and what is the force in the spring? We say, sir, force in the spring will be K times of X. Now we said this force, upward force, will be equal to T plus T. So we say here, I can simply say that is K times of X will be equal to, we say, sir, 2T. Okay. Now tell me, what is the value of T? T we got as 50 Newton. So we say K times of X is equal to 2 into 50 is, we say, sir, 100. Now X will be equal to, we say, 100 divided by K. So X will come out to be, that is 100 divided by, what is the value of K? K is given as 200. Okay, so that is 0.5. That is 0.5, or we can say 1 by 2 also, or we can say also that will be 1 by 2. You directly write it meters. Okay. So means in this particular case, we say this has elongated how much? We say 0.5 meters. That is 50 centimeters. This has elongated. X is the elongation in the spring. If this is the block over here, how much it has elongated the spring? That is, we say, sir, 0.5 meters. Hey guys, tell me in the chats if this is crystalline clear. Tell me in the chats if this is crystalline clear. Everybody out there. One more question. I would want you guys to solve this also. I would want you guys to solve this particular question also. Everyone. Now see guys how we can solve this particular question. We say on this block in the downward direction mg will act, and this is theta, this angle will be, if this is theta, this is theta, so this will be mg cos of theta. What is the force in this direction? This will be mg, and this is sine of theta. Now guys, see. And if in this direction this is mg sine theta, in this spring it will be k times of x. This is the force over here. Now, this k times of x will be balanced by mg sine theta. We say here, we say mg sine of theta will be equal to k times of x. And here you can find the value extension in the spring, that is x is equal to mg, then we say sine of theta divided by k. This is the value of x exactly over here. The last topic of this particular chapter, that is pseudo force. The last topic of this particular chapter is pseudo force. Guys, see, let me finish this particular topic in next 15 minutes and we are good to go. You guys will go, I'll also go. Now see, when it comes to the pseudo force, a lot of people feel that this is the difficult topic, we are not able to understand, okay, this is messing with our mind. But let me tell you, we'll kill this particular topic, that is my guarantee. Before that, I would want you guys to hit the like button, everybody out there. Now see, guys, let's suppose there is a person over here. This person is at rest, okay? Now on a straight road, there is a block present over here, okay? This is a block present over here. If I'm looking at this block at very far distance, from very far distance, what do you think? Will this block look like to you that it is in motion or is it at rest? Sir, obviously I am at rest, so this block I'll be saying it will also look to me it is at rest. So it will be at rest, okay, according to this person. Cool, yes. Now, if there is another person, okay, this is moving with the constant velocity. This is moving with a constant velocity. Now, here is another block which is present. This block is at rest. This block is also at rest in reality. What do you think according to this person? So this person will say, the block is coming towards me. So this person will say that the block is coming towards me with a constant velocity, So this person will say that the block is coming towards me with a constant velocity, okay? So you do, yes, it is because of the relative velocity, okay? This velocity of A, velocity of B. You can say velocity of B with respect to A, that is VB minus VA, it will have. You imagine it sometimes, okay? You place something at a very large distance, then you come in the car, okay? It will feel that the block is coming towards you, but in reality, the block is at rest. Now, guys, see, this is what we call, if the observer, this guy is observing this block over here, then this is what we call the observer in inertial frame. When the observer has got the constant velocity or the observer is at rest, that is what we call the inertial frame. Write down it in your copy. When the observer is at rest and moving with a constant velocity, we say observer is in the inertial frame. Now, if let's suppose I have got this particular person, Now it is moving with the acceleration a. It is accelerating. It is moving with the acceleration a. Okay. Now, if I say I have got a block placed over here, don't you think that according to this person, we say this person will say the block is coming towards me with the same acceleration a. But in reality, the block is at rest. In reality, the block is at rest. But according to this person, this block is coming towards this particular person, we say with acceleration a, same acceleration a. So here we say observer in non-inertial frame. Guys, always remember, when observer is having some acceleration, in that particular case, we say observer is in the non-inertial frame. If at rest and constant velocity, observer is in the inertial frame. So in case of non-inertial frame, it feels that the block is coming towards this particular person with the a acceleration according to this person. Okay. Now tell me one thing. Guys, see. I say if I have got a block over here, I say this block has got an acceleration a. What does it mean? Sir, it will only have acceleration if there is a force acting on this block. Because we say when there is force, there is acceleration, because we have studied Newton's second law, F is equal to mass into acceleration. If you apply the force on anybody, we say it will accelerate. If anybody is having acceleration, means force is acting on that body. Do you all agree with me? Yes. Now, does this block has acceleration in reality? No. But according to this person, it has acceleration. So whatever the acceleration of this block is, this is a fake acceleration over here. This is not the real acceleration. This is the fake acceleration. So we say if it has acceleration, there will be force acting on it. Okay. There will be force acting on it. And that force is what we call the pseudo force. This force is pseudo force. Why, sir? Pseudo force means fake force. If this is not the acceleration in reality, so there will be the force acting because it has acceleration. According to Newton's second law, force should be acting. Now, what is this force? This force will be also fake. Pseudo. Like this acceleration is pseudo acceleration. This is also the pseudo force. That is the fake force. Okay. In reality, there is no such force. But according to this person, we say pseudo force is acting on this block. That is the fake force. Okay. So I'll write the same thing over here. We say according to the observer in non-inertial frame. According to the observer in non-inertial frame, we say block will accelerate with fake acceleration. Means there is no acceleration on the block, but according to this person, it says that it has acceleration. So means fake force is acting on it, which is called we say pseudo force, which is called pseudo force. Is this clear? So pseudo force is nothing but a fake force. And what is the value of this pseudo force? Sir, it is simply that is mass into acceleration. Sir, when this pseudo force acts on a body, when observer is in the inertial frame. So write down this point also. We say it acts on an object if the observer is in the non-inertial frame. If the observer is in the non-inertial frame. If the observer is in the non-inertial frame, we say then only pseudo force will act. Okay. Now guys, I hope this is clear. I hope this is clear. Let me show you this. Yeah, okay. Find the pseudo force on the block. Guys. We say there is a car, it is accelerating with 3 meter per second square. And this is the observer in the car. Now, is the observer in non-inertial frame or inertial frame? Sir, obviously, observer is in the non-inertial frame. Why? This bus is accelerating with 3 meter per second square. So acceleration, observer has the acceleration. So can I say in this particular case, on the block, pseudo force will act? Sir, pseudo force acts oppositely, something like this. Okay, this is the direction of pseudo force which is mentioned. Okay, because if the acceleration of the observer is this, of this acceleration is this, on the block, acceleration will be in the opposite direction. Like, see. Here. Acceleration of the observer is forward. We say on the block, acceleration is opposite to this. Observe, acceleration is opposite to this. Now tell me, what is the value of this pseudo force? F is equal to mass into acceleration. F is equal. What is the mass over here? That is 5. What is acceleration? That is 3. So that is 5 into 3 is, we say, sir, 15 Newton. That's it. How you are supposed to apply. Now in this particular case, guys, here. This person is the observer. Okay. Observer in non-inertial frame. What is the acceleration of observer? Backward. So we say on this block, acceleration will be opposite to the acceleration of observer. So this will be the pseudo force over here, FP, pseudo force. So I can say this FP pseudo force will be, that is mass into acceleration. What is mass? That is 5. What is acceleration? 4. That is 20 Newton over here. Always remember, whatever is the direction of acceleration of observer, so we say on the block, acceleration will be opposite to that. Okay, next we have got lift weighing machine problem. Now see, this is important. Guys, see, let's suppose I have got a lift over here. Let's suppose I have got an elevator over here. Okay. This elevator is accelerating in the upward direction with a acceleration. Okay. Now we will place a block in this acceleration. It has mass m. And there is a person over here. Okay, let's not place the person over here. This is the mass m. And there is the person exactly outside of the elevator, which is at rest. Tell me one thing, my dear friends. We say over here, this person is at rest. Is this observer in the inertial frame, or in the non-inertial frame? Is this observer in the inertial frame or non-inertial frame? Obviously, it is in the inertial frame. Why? Because it is at rest. Now, guys, I ask this person, what is the normal force of the block? What is the normal force of this block? We say according to the observer in we say inertial frame. According to the person, according to the observer in inertial frame, we say what is the normal force of the block? Guys, he says that, sir, on this block, normal force is acting in the upward direction and mg is acting in the downward direction, and the lift is accelerating upward. Guys, see, the lift is accelerating upward. So we say I can use net force is equal to mass into acceleration. He says that I will tell you what is the value of n. So what is net force? Sir, upward force minus downward force. He says that is n minus mg is equal to mass into acceleration, that is m into a. So n will come out to be, n is equal, take it over there, this is ma plus we say, sir, mg. This is the value of This is the value of normal force. This is the value of normal force of this block, MA plus MG. Now, let's suppose we'll place another person over here inside the lift. Now, this person is right now in the non-inertial frame. Now, we say according to the observer, in non-inertial frame. According to the observer in non-inertial frame. Guys, see, when the observer comes in the non-inertial frame, I told you, we apply the pseudo force on the block. If the acceleration of the lift is upward, so same will be the acceleration of this person. Now, can I say on this block acceleration will be opposite and pseudo force will be opposite? We say pseudo force on the block applies only and only if pseudo force on the block applies only and only if the observer is in the non-inertial frame. Now use the Newton's. Now find the normal force. Guys, see. This person says that in the upward direction force, see. Guys, with respect to this person who is inside the lift, this block is at rest. With respect to this person, this block is in the motion. Why? Because lift is going up, block is going up. So with respect to this person, this is at rest. With respect to this person, this is at rest. So if this is, why? Because I can see this block, it is at rest. It does not go up, it does not go down, it is at rest. So this person is saying that if it is at rest, upward force is equal to downward force. So upward force is N, downward force is, we say, sir, mg plus pseudo force. Pseudo force is equal to mass into acceleration, m into a. So guys, in case of non-inertial frame, you have to apply the pseudo force on the block. If you do not apply the pseudo force on the block, the answer will be wrong. In that, then the answer will be N is equal to mg only, which is a wrong answer. What is the actual answer? This is the actual answer, mg plus ma. So if you apply the pseudo force, then only answer will be correct. So I can say Newton's laws are invalid in the non-inertial frame. Guys, Newton's laws are invalid in the non-inertial frame. Why? Because if we use Newton's second law, we say, sir, in that case, N will be equal to mg. But if you apply the pseudo force, then the answer will come out to be correct. Then the answer will be correct. See, why is it wrong? What is the actual answer? Actual answer is N is equal to mg plus ma. If you use without pseudo force, use the Newton's second law. You say, sir, that is N minus mg, okay, is equal to mass into acceleration. Acceleration in that case is 0. Why? Because this person saying, yes, sir, this block is at rest. If the block is at rest, it does not have any acceleration with respect to this person. So this will be 0. So take it over there. N will come out to be mg, which is wrong. Answer is this. So this is only possible if you apply the pseudo force over here. Now, upward force is equal to the downward force over here. Is this clear? Is this clear? Is this clear? Is this clear, everyone? So I can simply say over here N is equal to mg plus ma, and I can simply say over here that is, this is according to the inertial frame. But when you apply the, we say in the non-inertial frame, in that particular case, we are supposed to use this particular thing. We are supposed to apply the pseudo force, okay? We are supposed to apply the pseudo force. Everybody out there, is this crystalline clear? Is this crystalline clear? Great. Now, let's suppose I'll give you one more example over here. What is that? Let's suppose I have got an elevator, something like this. I have got an elevator, something like this. And it is accelerating in the downward direction. Okay. Now, I say I have got a block over here. You guys are supposed to tell me what is the normal force on this particular block. Guys, see, if I say there is a person over here, which is at rest, it is in the inertial frame. Okay. In this particular case, normal force is in the upward direction. We say mg will be in the downward direction. So with respect to this observer, this is A. We say according to A. According to A. Guys, according to A. Guys, according to A. Can I say this person is saying, sir, it is accelerating in the downward direction. Means this force is greater than this force. He is saying mg minus n is equal to, we say mass into acceleration, is equal to mass into acceleration. So this force, if acceleration is downward, means net force is downward. So we say this force is greater than this force. So that is, this one is equal to mass into acceleration. Net force is equal to ma. Now take it over there, take it over there. So n will come out to be, that is mg minus m into a. This will be the normal force, normal reaction according to this. Now, let's put the person inside this. So this is B. We say according to B. Guys, this B is in the non-inertial frame right now, accelerated frame. Now tell me, according to this B, he is saying that this block is at rest. So N is equal to mg in this particular case, which is wrong because this is the correct answer. So we say Newton's laws only becomes valid if you apply. If it is accelerating in the downward direction, you apply the pseudo force opposite to that. That will be Fp. This is pseudo force opposite. Now tell me, in this particular case, what is the value of normal reaction? Guys, see, now according to this person, upward forces are equal to the downward forces. What is upward force? That is N plus pseudo forces, we say, sir, m into a is equal to downward force over here is, that is m into g. So N is equal to, we say, mg minus ma. So we say Newton's laws become valid only when you apply the pseudo force in the non-inertial frame. Okay. So guys, that's all for today. I would want you guys, see. There is one more question. This is the homework. Okay, this is the homework. I would want you guys to put up the answer of this particular question in the comments later on, and do let me know how was the session. All the people out there, I would want you guys to let me know later on in the comments, not in the chats. Later on in the comments, how was the session? Did you guys like this session? Okay, so I have covered each and every single thing. I would want later on you guys to tell me how is the session, each and every single. And if you have not liked the session yet, I would want you guys to like it as soon as possible. Hit the like button, okay? Make the like count to increase, okay? And do let me know later on how was the session, okay? So thank you so much. Take care and bye-bye. Take care and bye-bye. So see you guys very soon. See you guys very soon. And one more important thing I just want to tell you. Sir, what is that? What is that? That is recently in this particular case, recently, see, I'll just write over here. That is, thank you. Okay. So see you guys very soon. So in the next session, till then, bye-bye and take care. So thank you so much. Take care, take care, take care. See you guys very soon. All the people out there. Thank you, thank you, thank you. Okay. So do let me know in the comments later on how was the session. Take care and bye-bye. Thank you.